In this video, we're going to take an overview look at abstract classes and the template design pattern in the Java programming language. In a following video, I'll show some examples. First, a bit of definition. Polymorphism. You might have heard me say this before, but just in case. Variable type tells you what methods you're allowed to call, and object type tells you what happens when you call those methods. This is one of the four fundamental concepts of object-oriented design, the others being abstraction, inheritance, and encapsulation. But polymorphism, when we get to really understand it, can tell us a lot about how to build a flexible and future-proof program. Now here's a question. If I'm a superclass, how can I get a hook into my subclasses? In other words, how can I ask my subclasses a question? And to complicate matters, what if those subclasses have not yet been written? Well, let's consider a few things, and let's kind of review a few things we might already know, or maybe we don't know. But essentially what we have here is a superclass of some type and a subclass of some type, and we have another class that has an object of this subclass, and it is invoking the execute method. Now take a look at what we have here. What would we call this? The execute method is defined in the superclass, and let's assume it's not private, and it is not defined in the subclass, but we can invoke the execute method on an object of the subclass type. Well, this is what we would call inheriting the method or inheritance, because what's happened is while the subclass does not have the method execute, it is inheriting the method from the superclass because the method is not private in the superclass. So when we invoke the execute method on an object of the subclass type, it simply delegates upstairs and it inherits the behavior from the superclass. Let's consider another example. What if we had this? In this case, we have the superclass with an execute method. The subclass has a method with the exact same signature. In this case, the subclass is overriding the method from the superclass. Don't confuse that with overloading. Very easy to get those confused. Overloading is the same method name with a different parameter list. That's not what's going on here. This is overriding. Think about our Prius and the Go method. The Go method in Prius is overriding a Go method in vehicle. So this is what we call overriding. When we invoke the execute method on our subclass object, we're going to get the execute method here, which is overriding the execute method of the superclass. Now, let's consider the case for our current scenario, which is our superclass wants to make a call into the subclass. This is unique because the superclass might not know who its subclasses are. As a matter of fact, it's better if it does not know who the subclasses are, because that lets us create subclasses in the future which naturally have not been created yet. What we can do then is we can declare the superclass abstract, and we can give the abstract superclass an abstract method. Now, abstract class, abstract method, it's kind of a hybrid between an interface and a traditional class, because an abstract method does not have implementation. It's just a method signature. And any class which subclasses an abstract class has to provide a definition for all of the abstract methods that were defined in that superclass. So in other words, it's like an interface, because if I'm a subclass and I extend from the superclass, and the superclass has an abstract method, I'm under contract, I have to provide a definition of that abstract method. Notice the subtle difference here. Semicolon here, open curly, close curly here. Semicolon means method signature here. Open curly, close curly means behavior down here. So in this case, what makes this interesting is the superclass, while it's only defined the method signature of hook, it can invoke that method. And what's really interesting about that is when the superclass invokes that method, it's actually going to be calling the method implementation in the subclass. Now, one footnote here. Once you declare a class abstract, you cannot create an object out of it. You can only create an object out of its subclasses. That's a bit tricky, but it essentially means that you can only have an object of this type, not of this type. Therefore, there's always going to be an implementation of this hook method. So what do we need here? We need an abstract class. We can take an existing class and make it abstract, which is what we're going to do. And we also need an abstract method, where that abstract method is just a signature. Then when we subclass this abstract class, we give definition to that method. So this can be used in part of a design pattern called the template method design pattern. I really like design patterns because it's a way we can give a convenient name to a programming concept that can be reapplied in multiple scenarios. In other words, which is faster? If I say 2 buns, lettuce, onion, pickles, ketchup, mustard, cheese, and a 1/4 pound patty, or if I say cheeseburger. You know what I mean when I say cheeseburger. Same thing happens with design patterns. We take these things that are complex ways to solve problems, or maybe simple ways to solve problems, and we give them a common name that all programmers will understand just by that name, or most programmers will understand. So what I've just described to you is the template design pattern. And in that case, the abstract class defines a series of steps through abstract methods. And then each subclass, whether it exists now or will exist in the future, gives definition to those methods. So this has been an overview of abstract classes and abstract methods. In our next video, I'll show a demonstration. I look forward to seeing you then. Thank you.